Welcome to module 15 of object oriented analysis and design. Over the last 4 modules, we have been introducing about the nature of objects and classes and their relationships. In this module, we will talk about a few basic parameters to decide how to build classes and objects of good quality. That is what defines if my design of classes of objects is good, is moderate, workable, or it is pathetic and will cause me a lot of pain. So, in this module we will briefly introduce some measures of quality, and then on the specific aspects of design, like if I am doing a class design, then I need to decide on the operations, the relationships, and certainly finally the implementation. I will highlight the core issues that need to be you need to take care of, you need to be careful about when you do these designs. So, in terms of the measure of quality, a lot of after a lot of years of research and experience of various projects, successes and failures, the community has more or less agreed to use 5 major measures to decide whether an abstraction has been captured well or there is scope for improvement. So, the first is coupling. Coupling basically says that if I have 2 classes or modules, then how coupled they are, how closely interrelated they are. Now, certainly if 2 classes are, there are 2 different classes and there is a lot of coupling, that this class uses a lot of information from the other class, that class uses a lot of information from this class and so on, then certainly it may not have been a good idea to make them as separate classes. They should have been in the same module, should have been in the same class. So, that is what we are talking about, that if we have the 2 classes and the coupling that we have, which is basically the density of messages that they need to exchange, should be low. So, the interclass coupling should be kept at a minimum. Now, of course, this will contradict one of the earlier design principles that we have been preaching, is inheritance is a good idea, because it gives us a good hierarchy. But certainly, if we are using inheritance, then we have a very high coupling, because any super class, rather any subclass will use the whole lot of information from the superclass. So, there is a lot of coupling in them, but so there is always a trade off in terms of how much you couple or how much you use the inheritance of. The second principle or second measure is cohesion, that is, if I have an object, if I have a class, then all the data members and methods, messages that exist, whether they should be together. Am I putting too much into one class, that is things which are not related, am I putting them together? We will have to decide based on that. So, cohesion must be high, which is intra class, all different methods and members that we put in a class, they must be closely related. So, we had discussed this overall in terms of different aspects of separation of concern and all that. These two, we had always said that between 2 entities, between 2 modules, the traffic that goes across modules must be significantly low, whereas the traffic that goes within a module must be significantly high, and that is the basic meaning of coupling and cohesion. So, those turn out to be the measures as well. The second next 2 measures are also related. One says that the design should be sufficient, that is, you should do a minimalist design, you should not do a design which has a lot of methods in the interface which may not be necessary. For example, you are designing a stack, we always talk about designing stacks. So, there is a push, there is a pop. I could think about a method which does a double push, that is, it takes 2 elements and pushes them one after the other. I can do that. I mean, that way also I can make the semantics of stack correct, but that is not something that is a good design, because it goes against the minimalist principle of design. it is possible to do with the standard push. So, I should not have a double push kind of operations available on the on my stack. And completeness on the other aspect is on the other side, which says that in terms of the design, have I covered everything that I needed to cover. For example, if I design a stack which has a push, pop and top and does not have an empty, my analysis, by analysis I must be able to reason that this is not a complete design, because there will be situations where you will not know whether you should actually invoke top, send the top message, or you should actually invoke the pop message by adhering to the contractual guarantees that we have talked of. So, in this way the sufficiency and completeness are two measures that we regularly should apply whenever we are designing the class. And finally, it is the primitiveness. You have to decide in terms of what is the primitive that you build with. Now, certainly few primitives have to be given by the OOP language that you are using. So, they are typically the built in types. Those are the representatives of the classes, but based on that what you decide to be different classes define is based on the primitives that need to be performed. So, this is a kind of a subjective decision, but it will depend significantly on what can be efficiently implemented. So, these 5 principles of measures of coupling, cohesion, sufficiency, completeness and primitiveness will be necessary for judging any abstraction. So, whenever a design is done, you should try to focus on doing these measures and checking out if you should improve on the design. Next, we will let us talk a little bit about how should you choose your operations. So, that is the first thing you need to do. How do you get started with the class design? Certainly, we have seen that the whole scenario is a client server based, where there are clients, there are servers and messages passing between them. So, the first thing that certainly we need to decide is what could be the set of messages, what could be the operations that need to be supported for a certain class, before we can talk about what is its internals or what is its relationships with others. So, when you are crafting an interface is not an easy problem at all, but when you are crafting that then you need to primarily take decisions about these two aspects. One relates more to the overall behavior of the interface, and the other relates more to the non-functional implementation related nature of the interface, the functional semantics and the time space semantics. So, let us talk about this one by one. In terms of functional semantics, that is what should be the different methods that you perform, that you provide to the class. There is a big trade off is, I mean these are standard prescriptions from very successful designers, but I will put it in very simple 2-word terms for you to remember. Is when you are designing operations, when you are designing methods, you have to always make a trade off between being too fine and being too coarse. What I mean is, if you have operations which every operation which does very small things, like I have an operation which just increments a value, I have another operation which just takes a number and takes out the LSB of that number and so on, probably I am getting too fine. At the same time, if I am designing for a bank account management and I say that I have one interface through which the user name, user ID and password is taken, it is authenticated, the account is identified, it is displayed, and with that within then the same method itself the account balance is shown. If there is any overdraft default, that message is thrown out and so on, all of that I will do in a single message, in a single operation, then I am getting too coarse. So, that trade off is very important, and certainly that is where object oriented analysis and design become somewhat little bit towards arts field than being a very concrete science, because you cannot exactly ever say as to what is too fine and what is too coarse. but you will always have to ask yourself this question. So, whatever operation you design, you think, I mean, should I have broken this down into 2 or more other operations? At the same time, ask for the class that given all these methods, is there a scope to combine 2 or more operations and do something better. For example, I could talk about stack. You will find in many textbooks you have an interface for a stack where the push works in the same way, but pop has a definition that removes the topmost element and returns you that element, and there is an empty. Now, if you define a pop like that which removes as well as returns you the element, then you will have to put a judgment as to, are you making it 2 cores? Should you split this into 2 operation in terms of one which removes the element and one which returns the top element, and based on that you should do the design. And a quick analysis in this case will tell you that it is always better to have a separate method to return the top element and a separate method to actually remove the top element, which then you do not return. Very simply, because if you do not have a top, you use pop to do all that, then after pop is the only way to check an element. So, if after checking that, if you feel that you did not want to remove this element, then you will again have to push this element back. So, that means additional work, that means additional time, and in some cases it might mean a very different semantics. So, that those kind of choices are what is important, and to place a method, that is, if you find that okay, this is the operation that I can see, then I need to find out an appropriate class for doing that, decide whether there should be a class for this. These are the factors that you should keep in mind, that certainly you should put it in a class which can be reused. You will have to look at what is the complexity of its implementation, how often it can be used, and of course, it will depend on the knowledge that you have, the designer has, in terms of the behavior, implementation, the platform dependence, and so on. But these are some of the factors that we will need to keep in mind in deciding how we close on the functional semantics of an operation. Now, once we have the functional semantics, then there are factors relating to more details of implementation, and some of the questions that need to be answered is in terms of amount of time and amount of space. Certainly, you will need to have some idea as to what you want. For example, if you are a very archaic example will be about finding elements from a large pool of existing data elements. So, if it is important that you need to find the elements very quickly, then you will possibly design the operations in a way so that time is optimized, but you may be able to afford some space. But it could be other ways if you really do not care about how much time it takes, but you are trying to implement the functionality of this search on a mobile phone, where space is a bigger premium than time. So, those are the time space semantics that need to be decided. You could do that based on a base case, average case, worst case, and so on. And specifically recall that whenever you have operations, the operations are messages acting on objects. Objects are in a concurrent situation. We have explained this different situation of synchronization between them. So, the time space semantics also will have to look into whether there is a need for synchronizing, whether there is a need for mutual exclusion that you need to put through in the design. So, your overall choice of operations should be guided by this requirements of the functional semantics and the time space semantics. Moving on, once you have chosen the operations, the next would be to choose the relationships amongst classes. What it means that, suppose I have say I have object x, I have object x and that sends message m to object y. Now, certainly this message m is what I have decided on, because I have chosen my operation. So, I know the message m, it will. Now, once we have that, then naturally if this message has to be sent either directly or indirectly, the necessity would be that y must be accessible to x. That is, in terms of different encapsulation, visibility restrictions and so on, unless is y accessible to x, this message design, the operation design will not work. So, the relationships have to be chosen keeping in mind the different choice of operations and the way you have started doing the design. And there are two principles which people follow very frequently. First is the law of Demeter. The law of Demeter says that in terms of choosing the relationship, you have to make a lot of trade off judgment, which is the first time I am just trying to use one inheritance hierarchy to explain this, that I can have a hierarchy which is more like say like this. One base class, one super class, everything else is a leaf child class, is one kind of hierarchy, or maybe not only that, but I have this, but then lot of here. So, these kind of we will say are wide and shallow, that is where the depth of the hierarchy is less, but the breadth is very high. So, if the breadth is very high, then you have a large number of leaf classes. So, it will give you a forest. Now, certainly it is much less like a tree, it is more like a forest. So, all these leaf classes are independent. So, if they are independent, they hardly share the properties that could have been shared. That is the basic purpose of inheritance, to share properties across classes. So, if the hierarchy is very wide and shallow, then you are not exploring the commonality that exists and you are missing out on key design clues that may happen. On the other hand, if on the extreme, if your hierarchy is very narrow and deep, suppose you have this, that is, this width is slow, but this depth is high, then also it will not be a good design, because you will have long chains of inheritance where you are just every class is trying to get something from the parent and so on. Possibly your fine grained is so much that you do not have a good manageable design. So, you would recall the kind of vehicle design we discussed about in the earlier module, the module 14. Those kind of are known as a balanced design, where you have kind of two extremes, that your depth is not very high, at the same time the width is also not very high. So, there is a fair amount of commonality that is exploited, at the same time in terms of exploiting that, you have not made the whole design very fine grained, and decide on that. The similar principles can be used amongst single inheritance in cases of aggregation, that is, how much to compose, how many different parts should I break it on to. Do I take, I mean, if I have to represent a car, do I take the car and then break it down to in terms of nuts and bolts and wires and connectors and seat covers and all that, or I do a hierarchical aggregation there, what is the dependency relationships and so on. So, on the same principle of trade off of what is very fine and what is very coarse, these relationship designs must be done, and also there should be design choices made in terms of how do you relate the class. For example, you have car and engine. Certainly, I just started saying that this is a case of aggregation, but who said this has to be a case of aggregation? This is aggregation is one way of looking at it. So, car contains engine is one view. Now, could I say that car inherits from engine? It is a specialization of engine. We will have to see whether that makes sense, but we can certainly say that car uses an engine. You think of car as a separate entity, engine is a separate entity, car uses an engine. So, there is certain decisions to be made in all these cases as to which one is the right way to relate different classes, and accordingly you can make the you should make the choice, and that is what the law of Demeter talks about. Besides that, you will have to look into the mechanisms, the feasibility requirement. Suppose a passenger intends to board a bus. So, there is a passenger class, there is a bus class, and you need to place the board method, and for that board method you need to have the visibility between passenger and bus. Now, there are certainly three choices. You can have a board method in passenger and let the bus go as a parameter to that. So, that where you send that, or the bus can have a board method with the passenger sends it and goes as a parameter, or both could have board methods which collaborate between themselves. Now, depending on which class has the board method, the visibility will have to be accordingly. For example, if bus has a board method, then bus must be visible to the passenger. So, that passenger can send the message to it. So, these are the different choices in terms of mechanism and visibility that you will need to apply to decide on the relationship. The third aspect in terms of the quality of design will depend on the implementation, which often would mean a lot of skill, lot of understanding of your vehicle of implementation, that is the implementation OOP language as well as the platform. I would just like to highlight that two factors that need to be critically looked at regularly is the representation that you are using for the class and the packaging or the placement of the class. That is, in a large system there are large number of classes, objects, objects occurring. Now, you need to certainly group them into certain subsystems, certain modules. So, the representation has to be appropriate as well as the grouping has to be appropriate. So, that again the traffic across modules can be minimized and they can be more cohesive in that form. So, representation should be done in a way, so that you remember the basic principle of the implementation, that implementation must hide. It must encapsulate all the secret, all the details of the implementation. Couple of modules back, while discussing about the nature of classes, I talked about these aspects with an example of a stack, and I show that how for the same interface we could have multiple different implementations of a stack, which could change irrespective of which interface the customer is using and without the knowledge of the customer. So, that is a very basic requirement that any implementation must satisfy, that any change in the implementation usually should not impact the contract, interface contract with the customer, and that is what you should try to follow. But there are several trade offs to be made, several choices to be made. For example, some of the common ones are should I optimize for space or should I optimize for time. The new dimension being added in many places is should I optimize for power. Similarly, in terms of any application that needs to do some kind of a search somewhere, there is always a choice between do I optimize on search or do I optimize on insert delete. We all know that if we use some kind of a array structure, we will have very optimal search, but very inefficient insert delete. If we do a list, insert delete is very quick, but the search gets very slow. If for that we want to do a binary search tree, then possibly these two get balanced, but I need more time, rather I need more space, because now the binary search tree has different pointers to be managed and so on. So, there are different choices. Another very common choice in terms of the class design that you will need to do is compute or cache. That is, there are several values which you could compute on the fly or compute once and keep it stored. I will just give an example. Suppose you regularly need the age of an employee. Now, what you could do is naturally age is dynamic, so it does not remain the same. So, what you do, you keep the date of birth. And so, what you could do, whenever the age is required, you could compute the age and return that. Typically, you do not need the age in the granularity of days, you need it in terms of years. So, one way could be that every time you do this, that is basically compute choice. The other way could be that you have a age field and which you compute on 1st January for all employees. because your logic is that within that year the age will not change, or whatever changes will happen, that is just for 1 year, which does not impact you, or on the date of birth of that employee you compute the age and store it. So, what you are doing, you are caching the computation. So, there is a trade off between which one should be used, and these different factors will decide what kind of representation, what kind of implementation you will choose for. Finally, in terms of packaging, you have to put the classes and objects in modules. If you are using a platform OOP language like Java or C#, then you will, these are actual physical decisions, because you have to decide which Java package some classes go in, and the other classes will possibly go in some other package, and so on. If you are doing in C#, you will have to decide on the projects. If you are doing in C++, you will need to decide on your own packaging in terms of different source files, header assemblies, and so on. But this is a very critical decision to make, because this will directly have an impact on the visibility and information hiding, the trade off between visibility and information hiding. Because if you put certain classes together into one module, then it is much easier to make them mutually visible and hide all of their visibility from someone who is not in the same module, and so on and so forth. So, those are the factors in packaging. Besides that, there could be a lot of non-technical factors, like how you want to reuse. If you want to reuse something across variety of different modules, you would not like to put them hard into one module, but maybe have a separate module for it. The security could be a matter, the documentation, several other factors which could impact the choice of packaging in implementation. So, to sum up, in this module we tried to introduce you to the concept of having certain quality measures for designing the abstraction and for designing the classes and objects in terms of coupling, cohesion, sufficiency, completeness, and primitiveness. And then for the 3 major aspects of the design, dealing with the choice of operations or methods, the choice of relationships between classes, and finally, the choice of implementation, we have tried to talk about some of the pain points that can happen in the whole design, some of the parameters that you need to keep in mind while you go ahead with the design. We will take this forward in the modules for the next week, where we will expose you with different semi-structured techniques of identifying objects and classes and relationships. And as you do that, all these principles that we have talked about in this module, you should bear in mind, and more you can put them into practice, you will become a better designer of the object system that you are given to work with.